So now that we did have a look at what information are generally on a transaction output, and in particular, we did have a look at the structure that data in general can have, which will turn really useful in the following videos. We'll go ahead and have a look at why dedicate an entire video to addresses, because there are many variants of an address, and it is really important to understand the difference. Of course, as always, you can find all the details on the documentation. But this time we are going to look directly from here. The address is, there is a bunch of information as always. And we can see this information by console log, JSON, Thingified, and then address to JSON. First, we want this nice format. So we will format this tree. So we go ahead, we are in the addresses directory. So if we run this code, we can see how this address is. And so we go ahead and do npm run start, and here. All right, yeah. So we will not have JSON, instead we will have just address here. This will not look pretty, but it's better than nothing. So yes, here we see that an address has a bunch of information. The first important information is that this address does only work for test. There is a distinction between addresses from mainnet and addresses from test. The other two really important information are the payment credential and the state credential. So other than the testnet and the type, the real informations are here. We see that there are two parts that do form an address. The one is the payment credential, the one is state credential. So, going back to the network, I will show you that the network is very important, because if we take the same exact rest of the info and we only change the address, we'll see that the mainnet address equivalent of these keys So if we instead change the network as we are doing here, we are constructing a new address using the mainnet static method, and but we are using the same payment credential, the same state credential. So this same that we have here for the same address. So we are only essentially changing these tests, and we can also show that here by console log, and we pass here the my address. We can show here that if we run this code, we see that this is the first console log. So this is the address from the testnet. This is the address, new address that we have constructed, that is the mainnet address. And we see that here the network has changed. And well, we don't really see the bytes here, but we are taking the same stack that we have here, accessing this queue. So these are the same. And we see that the address has totally changed. Not only the part that begins with, in fact, on mainnet, we only have add as the initial part, instead in the test that we have add underscore test, but we have changed totally how the rest of the address looks. So this is the very important first piece of information. There are two kinds of addresses. If we are in testnet, the address doesn't care if it is which testnet in particular. It just cares that it is not mainnet, essentially. And of course, it cares if it is instead. The second difference is that if we go look here, the mainnet, or in general, any address structure, will only require us to pass the payment credential. If we remove this, Typescript gets mad and says, okay, look that I need at least the payment. So we give the constructor the payment credentials, and now it is happy. It doesn't require to have a state credential. So we can have addresses that only have payment credential and no state credential. And we see that these addresses are shorter. This is, of course, because we are missing state credential. These two parts of the addresses, the address is structured this way because there are different purposes which these two parts of the address can be used. The first part of the address, the payment credential, the one that is strictly required but in order to have an address, is the part of the address that determines the UTXO. Determines the key that needs to be used in order to spend UTXO. If you remember, in the first transaction that we built here, we have derived the private key at this path. And this path is only the payment key. If we wanted the state key, we would have had to derive also this other part. But since we are not really using this stake part of the address in this transaction, we only derive the first part, first half of the address private key, and we use only that private key in order to spend UTXO. The first part of the address, so the payment credential, are only used to spend UTXO. The second part of the address, if we go back here, is instead used for staking. So as we know, Cardano is proof of stake, and that means that you can stake your fund. Particularly, you can stake your ADA. Those ADA will remain in your wallet. You will still be able to spend them because that is related to another key, of course. But in order to make decisions related to your stake, you will need instead to use that other half. And you are this on Cardano, you are not forced to stake. Cool. You may have an address that doesn't have a stake key. That will be shorter because it's missing the other half. So you're not forced to stake. But if you want, of course, you will need to expand your address. And this longer address with two parts, this is exactly what allows you to spend your funds while also staking them. So if you do not use your funds, those funds are staked. But if you are using them, you're using the other of the address. This is the other important concept is that you have a payment credential and a stake credential. Both credentials can be either a public key hash. Also here, this stake key hash is essentially a public key. And what does that mean? That means that if we go back here on the first transaction that we did, this is a private key, public key hash. And it is essentially, we have this private key. From this private key, we can do something like private key dot public, and we have derived the public key, in this case the extended public key. Well, here we will need, in this particular case, to do some other operation, such as wrapping it in new public key, dot public key, key from yes. And given this public key, we can get the hash of the public key. And this hash of the public key is a public key hash, of course. The difference between a public key and a public key hash is that the public key is of length 32, whereas the public key hash is of length 28. This is because a different hashing function is used. In any case, this doesn't change. So we can remove this. This was done only to show you that for each private key, we have a corresponding public key that we can derive. And then from that public key, we can get the public key hash. The public key hash is what is stored in the payment credential. And the same goes for the stake. This kind of difference, if we see payment credential is of type credential, we can also construct independent credential type. So credential, you will need manually import credential from yes, because if you're in Node, these are Node.js credentials. There is a conflicting name, but should not be a problem. So we import credentials from plu-ts. So now this credential is of plu-ts, and we see that we have a bunch of methods, of which two are function. One is key hash, so we can construct a payment credential from a public key hash, as we did here. So we can pass something like address.paymentcredential.hash, and what we have here is just the credential that will be used later to build. This is exactly what we have here, essentially. But this credential can also be script. And in case it is a script, this address will change again. So if we now use this script credential with this hash, and we construct a new address here, if we run this code now, we have essentially just took the address payment credential, so we are taking the same exact hash here, and but we are wrapping it in a script credential instead of a public key hash. So now this hash will be, as we'll see in a probably the next video even, this hash, if wrapped in a credential that is of type script, will be the hash of the compiled smart contract. So we can ask as payment credential part of the address, we will be able to have either public key, and in particular public key hashes, or we will be able to have hashes of script. The core difference is that, as we did here in the simple transaction, in order to spend a UTXO that is of an address, we need the respective private key matching this public key hash. In order to spend this, if we do not have that corresponding private key of the address credential, as you know, this UTXO comes from our own address. So if we do not sign, the transaction is not valid. In the case of addresses with the payment credential that are of kind script, of course, a script cannot sign a transaction because it is not human. So instead, when a transaction that is trying to spend an UTXO that is on an address of a script, such as this one, it will not look for the signature of the transaction. Instead, we'll look for the script to be included in this transaction in some way. It will run the script, and if the script does not fail, so if whatever logic is on chain corresponding to that hash of the script will not fail, then it will assume that the transaction is valid for the script. So that is, in that way, is as if the script signed the transaction. We will see all these in action as soon as we touch the script in this part 2 that is coming. But all this was to say that the difference in the logic for the validation of a transaction relies on the difference. And of course, well, the same can be done for the key hash. Is once again the public key hash just for stakes, for the stake part of the address. In the same way, the stake credential can be instead of a script. So we can have script also for all the actions that are related to staking. So we as we will see, there will be scripts that are only the only purpose, as an example, is just to validate the spending of a new. So in that case, the script will be used here. But instead, there could be a script that will validate when to withdraw the reward from staking or where to delegate the stake to which pool. We can do all these kind of actions with a stake that is instead used here. So this part is really important. Understanding how an address is formed is really important. And in particular, I will anticipate you this. Since we have addresses that are longer, we have, such as this one, and we have addresses that are shorter, we will need on-chain, when we run an on-chain smart contract, we are able to access both these parts separated of the address. On-chain, we do not have access to the string, this one. Rather, we have access to something like this. We have access to the hashes, and we have access to the kind. So if it is a public key, or so if it is a human, or if it is a script, we have access to this information, not this information. So this is really important. Especially when we will move to contracts, to understand where the funds are going. In most cases, there is a Franken attack, as an example. Only this part is used for spending. A general mistake that is done is only to check the payment credential to who we are sending the funds. However, an attack would send funds to the correct payment credential, but change the stake credential to be owned, so that maybe we are sending the ADA to the correct person, but those ADA will be instead staked with someone else. So knowing this difference between addresses is really important, and we will see how it is used in practice. Also, when we will go and look at the script.